Hey guys, this is Terence. Welcome to the new episode of RhinoPython and GhPython Playground. In today's video, we are working together to conquer a difficult topic, which is the Euclidean subdivision like this. The Euclidean subdivision is based on the Euclidean algorithm, as I mentioned last week. The algorithm enables us to create a mathematical pattern from a square or a rectangle. It's actually subdividing the square and the rectangle to many small pieces. And also we can apply this pattern on the building's facade, on the interior decorations, and any other kinds of artworks you can imagine. So let's get started. At first, let me draw some sketches to explain how the Euclidean algorithm subdivide a square. Now this is our target square. As we want to subdivide this square into many small rectangles, we need first define the width and the height ratio of our target rectangle. And for now, I want to set this ratio to 4 to 10 because the subdivision with this ratio will be very straightforward. Then I should define the total width of the square. I will make it 100, and we can start subdivision from the upper left corner. We define here as a start point with the coordinate 0 and 0. And we end up with the lower right corner. This is our end point with the coordinate 100 and 100. Now we will start to subdivide this rectangle along the x-axis. The condition we need to check here is if the start point's x coordinate plus the width multiplied by ratio is smaller than the end point's x coordinates. I mean, if the start point plus by our new width of the rectangle is smaller than the total width of the square, if this condition returns true, we can draw our first rectangle here like this. This is 40 because the width 100 multiplied by 4/10 is 40, and we will move our start point to this position. Then we use the new start point to check this condition again, and the condition returns true now, so we will draw our second identical rectangle here and update our start point to this position. The new coordinate is 80 and 0. And if we keep checking this condition, we will find the new value on the left side of this comparison sign is now 80 plus by 40 is 120. It's already larger than the x value of the end position. So this condition no longer returns true. We need to subdivide the remaining part of the square along the y-axis. And before doing so, we need to update our width value as the new width value equals to the end point's x coordinate minus the start point's x coordinate, and it's 20 for now. This remaining part is 20. The new condition we need to check is if the start point's y coordinates plus by the width divided by the ratio, if this value is smaller than the end point's y position, if this returns true, we can draw a rectangle here. And for sure, we need to update our start point to this position. This one no longer works. And we keep checking this condition. We will find we still can draw another small rectangle here. And we finished our subdivision. The different ratio we provided, maybe 6 by 10 or maybe 7 by 10. The different ratios will result in different subdivision patterns. And also it's very important to set the smallest width for the subdivision. If we don't, sometimes the subdivision will be stuck in an infinity loop. So we need to mark here. We need to set the smallest width. When the width is larger than the smallest width, we can execute the code. We can subdivide the square, or we just stop the code or stop the function. So this is the logic of the square subdivision. Let's now achieve this by GhPython. Let's start by setting up our basic working environment. Let's say, let's add a GhPython node, remove these two inputs, show code input parameter, and input is path. We can add another node called file path. Right click, synchronize, and select our code file. Connect the file to our GhPython node. And I also like to add the panel to the out parameter here. And I can use this to check if my file is successfully connected to this GhPython node. And in the code editor, I can say import rs.rhinoscript syntax srs and try to print something. Save it, and you can see the goal shows up in the panel. That means these two files are now successfully connected. Now let me remove this print syntax and start do some coding to subdivide square. So first, let's define a function called divide square, which requires, let me bring up this sketch. It will be much more straightforward. What we need is a start x, a start y value, the width of the square, and the ratio. We need it. And inside this function, we can first declare an empty list called rectangles, which used to store all our target rectangles. And we will define another variable called iteration. This is used to help us define which axis we should follow to divide the square. Then after this, we can say and x equals to start x plus by width, and y equals to start y plus by width. And these two values are the xy coordinates of our end position. And we can say while the width is larger than 0.1, that means our smallest width is 0.1. Only when width is larger than this smallest width, we can divide the square. And inside this while loop, I will first set iteration plus equals to 1, and if itr divided by 2 remains 1, and only when this condition is true, only when this iteration modules by 2 remains 1, oh sorry, this should be a double equal mark. Only when this condition is true, we check this condition. We can say while start x plus width multiplied by ratio is smaller than end x, and I'd like to add the end x with 0.1 just for safe. And inside this second while loop, we can say we can write a pseudocode here to say we will draw a rectangle. We will write this function later, just not for now. And also to check, after checking this condition, after drawing our first rectangle, we need to move our start point. And here we should say start x equals to plus equals to width multiplied by the ratio. And outside this while loop, we need to update our width equals to end x minus start x. And this is our first loop. This indicates the way we subdivide the square along the x-axis. And then else we need to write the code to subdivide the square along the y-axis. We can say while the condition we need to check is this one, while start y plus width divided by ratio is smaller than end y position. Also, I want to add 0.1 just for safe. And also another pseudocode called draw a rectangle. Then update the start y's value plus by width divided by ratio. Yes. And outside this while loop, we should update our width and y minus start y. And after we finish the code, maybe we need also to return these rectangles, although now we did nothing to draw the actual rectangle. And this is our subdivide square function. Now, above this function, we need to define another function called draw rectangle. RECT is okay. And we need a start point, x position, y position, the width of the rectangle, and the height of the rectangle. And inside here, we need first find the plane, or I can say the rectangle equals to rs dot add rectangle. Let's check what parameters or what arguments we need to pass into this function. We need a plane, we need a width, and we need a height. So this is what I just mentioned. We need a plane. And above this rectangle, we need to first declare a word xy plane, rs.word xy plane. This is our default plane. And then we should move this plane to our start point's position. We can say move plane with the target plane is is the plane we just declared here, and also the plane origin is our start point. From here we pass the star x star y value into these two values, and we can and we can say the target start point is x position, y position, and also with the z value of 0. And then we can pass the plane and the width and the height parameters into this function, width and height. And at last, we need to return the rectangle. Save the code, and we don't need it. Save the code. There is no error happens here, so our code is pretty decent for now. Then we should replace this pseudocode with the rectangle code we just finished. We can say the rectangle equals to draw rectangle with the start x, start y, width, and also here should be width multiplied by ratio, and the height is the width. And also we need to append this rectangle to our rectangles list. RECT. And we can copy these 2 lines of code to here and modify this part. Star x is okay, star y no problem, but here we remove this multiply and ratio. And here we add the divide mark and add ratio here. Now we finished the functions, but we haven't really run it. So down here, let's call this function to execute it to see if the function runs well. So here I think I want to add 2 parameters. To use these 2 values, create a ratio that can be used to divide our square. The first value could be 4 and the second value could be 10. Here and here, connect these 2 values to these 2 new inputs. And down here I can say num a equals to x. Oh, sorry. Num x, and number b equals to y, and the ratio equals to number x divided by number b. I prefer to wrap this expression with a float sign to ensure it returns a float value. And also something need to be care about is the x value shouldn't be equal to the y value. The ratio shouldn't be 1 or the function will stuck in the infinity loop. So we add another condition here. We can say if the number a equals to the number b. When number a is not equals to number b, we can run the following function. Now we have our ratio. We want to subdivide our target square. We can call the divide square function here. And start from 0, 0 with the width of 100. And the ratio is the ratio we just created. Save the code. And now you can see this is the pattern. The pattern is identical as we drew it in the sketchbook. And if we can change this ratio, we will get different patterns. And I think you guys can play with this. There are many different kind of possibilities of the subdivision. So this is our first step. The next thing we need to do is to subdivide the rectangle. And in the divide square function here, we actually subdivide the square into many small rectangles. While in the rectangle subdivision function, we will subdivide the rectangle into many small squares. Let me open up the sketchbook to draw some sketch to make things more clear. This is gonna be our target rectangle. And as we already defined the ratio in our previous function, we don't need to declare the ratio again here. And we will set the width value on this side, and this side is gonna to be the width divided by the ratio. And we can start subdivision from the upper left corner. We can say start point equals to 0 and 0, and this is our end point here, with the x value equals to width divided by ratio, and with y value equals to the width. And we will also start our subdivision along the x-axis. The first condition we need to check is if the start x plus by the width, if this value smaller than end x, we draw squares. And now we can draw our first square here, because the condition returns a true value. Square here, and then we need to update our start position to here. Remove it. And now with our new start value, we check this condition again. If this condition returns true again, we will draw another square here, and then update our start point to this position. And now you can see the start point's x coordinate plus width will exceed the end position's x coordinate here. So we will switch our subdivision direction to subdivide the remaining parts along the y-axis, and then we need to change the condition that we need to check. And the new condition, before doing so, we need also to update our width value. The new width value is gonna to be end positions x value minus start positions x value. This is gonna be our new width value. Then the new condition we need to check is if start point's y value plus the new width value, if this value is smaller than the end point's y position or y coordinates, if this condition returns a true value, we draw a small square here, update our start point, keep checking this condition, it is true again, then update our start point, then keep doing so until the whole shape is fully subdivided. And also we need to set the minimum width to avoid some kind of infinity loop. And let's apply these knowledges to our code to write a rectangle subdivision function. Let's go back to our code editor, and in here we define another function called divide rectangle, which requires 4 parameters: start x, start y, the width, and the ratio. It's identical to the divide square function. Column, and inside here we declare an empty list to contain all the future rectangles. Also, we need an iteration equals to 0. We set the end x value equals to start x plus width divided by ratio, and we set our end y value as start x plus width. And down here we we can say while. These two parts are actually pretty similar, so I can follow the same logic. I can say while width is larger than 0.1, iteration plus equals 1, and if iteration divided by 2 remains 1, we can say while start x plus width is smaller than and x plus 0.1, and we can draw a rectangle function here and pass the start x, start y, and width. Pass these 4 arguments into the function. And as we want to draw squares inside the rectangle, so the width and height value are identical, and we append this rectangle to the rectangles list. Then update our start x position, and should be plus equals to width, and outside this while loop, let's update our width value equals to end x minus start x, and else down here is the logic of subdividing the rectangle along the y-axis. We can say while start y plus width is smaller than end y plus 0.1. Then we copy these 2 lines of code. Too many indentations here. Okay, then update our start y value plus equals to width. Then outside the second while loop, we need also to update the width value that equals to end y minus start y. At the end of this function, we return the rectangles. Save the code. And now we will replace this function with the divide rectangle function to check if this function is doing well inside, and the result will shows up in our Rhino workspace. Let's do it. Let's remove this square, replace it with the rectangle, save it, and now this is our rectangle subdivision pattern. We can change the ratio, then we will get different results. We will have different pattern in different ratios. And for now, we finished the divide square function, and we also have the divide rectangle function. The next step is to insert the function. Insert these 2 functions into each other to create a recursive function to make the code keep subdividing to make the code keep subdividing these shapes. So let me bring up the sketchbook again to draw some sketches again to explain how the recursive subdivision works. Oh, sorry guys. Before we enter into the next step, I find I made a big mistake here. In line 38, we need to modify this start x with the start y. The start y is a correct value. Although the previous run edition still make this pattern, it will definitely cause a big problem to me if I insert this divide rectangle function into the divide square function. So please modify this value, modify this from start x to start y. The start y is the correct value. Sorry about this. Now I can open up my sketchbook and let me draw a square first. Assuming that this is our target square, this is the square we want to do the recursive subdivision. So we first call the subdivide square function on this square. When the function returns the first rectangle, we instantly call the subdivide rectangle function on this newly generated rectangle. And when this rectangle subdivide rectangle function returns the first subsquare, we instantly call the subdivide square function to subdivide this shape. So this is the logic of recursive subdivision. But you might notice that if we don't set an end condition, the shape will keep dividing itself infinitely. So the end condition helps us prevent this kind of endless recursive function. We can say the end condition is while some value, maybe the width, is larger than a thread value. Only when this condition is true, we can keep subdividing the shape. And while this condition is false, while the condition returns false, we stop the recursive subdivision and finish the current subdivision like this. And now, assuming that the width of this part is already smaller than the thread, now we finish the subdivision of the first rectangle. We go to the second rectangle and do the subdivision inside. Then we do the subdivision in the rest parts of the square. This is the recursive subdivision. And to achieve this, we just need to modify some lines of code in our current code. Now let me close this sketch and do some modifications. Let's first go to the divide square function here. Add a parameter called thread. Replace the 0.1 here with the thread. And we should do the same thing on the divide rectangle function. Thread. Replace this with thread. Then we should go back to the divide square function. Replace these 4 lines of code. Let's first remove them and say rectangles equals to plus equals to divide square. Divide rectangle with the start x, start y, with multiply by ratio, the ratio value here, ratio and thread. And we copy this line of code, paste here to replace these 2 lines of code. And here we should remove this multiply sign and the ratio here. So these 2 lines of code are a little bit different in the third parameter or third argument inside this function. This one is width multiplied by ratio, while this one is just width. And we do the similar thing in this divide rectangle function. We can say rectangles plus equals to divide square, start x, start y, with ratio and thread. We can copy this line of code, replace it with these two lines of code, and these two lines, the line 47 and line 42 are identical. Then we should exchange these two end values. I want to say the first one is end y, while the sorry, I can't do this directly. I can say end x equals to start x plus width, while the end y equals to start y plus width divided by ratio here. And we should modify this value. We should replace this value in line 40 with 0. And I think, okay, let's go back to the draw rectangle function. Wrap this rectangle output with a square bracket. That means we will return a list contains only one rectangle inside it. The final step is to draw rectangles inside this true function, because in both functions we already removed the drawing rectangle functions. So we should add them back, but in different position. We should add the draw rectangle function just right behind these two values declared. In line 16, I can say rex plus equals to draw rectangle, start x, start y, width, and width. And in the divide rectangle function, I can say rectangles plus equals to draw rectangle, start x, start y, width divided by ratio. I think we already finished the modification on these three functions. Then let's go back to the Grasshopper nodes. We need to add another input here, which is thread, but we call it limit in Grasshopper. I will set it to 20 and pass this limit value into our codes. I can say thread equals to limit. Oh no, limit. And to avoid the limit value becoming too small, I will add a line of code here. I can say if thread is smaller than 10, we fix the thread value to 10. And at the end here, we just need to add the thread value as the last parameter of the function and save the code. And you can see we basically achieved this recursive subdivision here. Let me decrease the thread and change the ratio. You can see we can have different recursive subdivision patterns. Sorry, I'm a little bit messed up. And here I can also change this function to the subdivide square function. We will get a different pattern. It is a square. We can change the thread. Then we can get different ways of recursive subdivisions. And to make things more clear, I want to extend my Grasshopper map. I want to first subdivide the list. No, I should say split list at the index of 1. Then deconstruct all the polylines. Explode, yeah. Down here, remove the duplicated lines. We should flatten this input. Oh, sorry, it should be disconnect this one it should be this one. Flatten it. And then with the A output, I will make it a square surface. I can use the boundary surface here. And use these lines to subdivide or to split this square. I will use the node called surface RFAs, surface split. And the surface is this one, the curve is this one, and hide all other values. If we bake this, you will find we have these small rectangles. Let's go back to perspective, remove this, and preview this. If we change the ratio, or if we change the thread, there will be a result here. So we finished all our tasks today. That's all we have for today's video, and this topic is pretty difficult because it requires a little bit knowledge of mathematics and programming. Please don't get frustrated if you feel it's too difficult or if you feel overwhelmed. It also took me several weeks to get through this topic. I already uploaded the code to my GitHub repository. You can find the link in the introduction of this video. And I really appreciate your patience of following this video. Please let me know if you have any thoughts or questions. So thank you so much for watching. Bye bye.